Problems in which you have to compare two or more options, in which each option has several different parameters or features, are the type of problems that it's often easier to just draw up a table. Gallant carpet cleaning here is a very good example of that. Gallant carpet cleaning cannot meet demand for its current equipment. Gallant carpet cleaning is considering 2 new carpet cleaning machines. Okay, there's your options. Machine A cleans carpets to residential standards. Machine B cleans and sanitizes carpets to hospital standards. Okay, that's nice. Now, this is what I mean by various parameters and options. Machine A costs $20,000. Machine B costs $50,000. The company estimates its cost per cleaning, including chemicals, for machine A is 8. For machine B, it's 7. The revenue for machine A is 40, and for machine B is 45. Whoa. A table. There are 2 options being discussed here. So I list them. Now, actually, to continue on with this paragraph, what is the actual question here? Machine B needs to clean how many more carpets than machine A to break even? Oh, that's what all this other information in here is about. It's about the break-even formula. Well, the break-even formula, in order to use it, you need fixed costs, you need variable costs, and you need revenue. Notice that in this problem, we have those 3 exact readings for each one of the options. Now, I'm not going to do any calculations yet. I'm simply going to arrange what I was already told kind of as a story in a table so that later I don't make a mistake in referencing which essentially number goes where. All right, machine A, fixed costs. Fixed costs are very often purchasing costs, because that's what you pay no matter whether you use the purchase or not. In the case of machine A, it costs $20,000 to purchase it, regardless of how much we use it. Classic fixed cost. In the case of machine B, $50,000. So I'm just copying the information down onto this table. The company estimates its cost per cleaning. Classic example of a variable cost, including all chemicals. Okay, for machine A is $8. That's that number. And for machine B is 7. Okay, that's that one. The revenue per carpet cleaned for A would be 40. R for revenue, 40 for A, and for B, 45, because it cleans to a higher standard of sanitation. Yeah, okay, fine. The only thing I've created here is a table. Why? Oh, because it asks about break-even. And we remember that the classic formula for a break-even quantity is fixed costs divided by revenue. Whoops, that's an R. Revenue minus variable costs. Oh, so I need to calculate this formula right here. Yes, I do. Actually, for this problem, gallant carpet cleaning, I need to calculate or use that formula twice, because there's 2 different options and we were given information to calculate. Essentially, oh, I can expand this table. I've got enough information here to calculate the break-even point for each machine. Oh, all right, so I should do that. Now, in the case of the first machine, machine A, I just need like an area for my sort of scratch work. Let's see machine A, I'll do it here. Machine A, I'm just calculating the break-even point using that formula. Okay, for machine A, that would be 20,000 in the numerator, divided by, okay, the revenue is 40 for machine A, minus the variable cost of 8. I get that that is 625. You know, that's the result of that formula. Filling that in on the table. Okay, so if Gallant Carpet Cleaning were to purchase machine A, they would have to clean 625 carpets in order to cover their costs. Now, wait a minute, what about machine B, the more expensive machine? Okay, some scratch work. Same formula, different parameters. Machine B, the fixed cost is $50,000, so that would be the numerator. The revenue is $45,000. The variable cost is $7,000. All right, I put that in my calculator, and I get a rather ragged number, 1,315.789, and it keeps going. It doesn't come out evenly, unlike machine A. Little just point to remember with break-even quantities. Machine B has to clean at least this number of carpets to just cover its costs. The thing that's a little awkward is that this is not a round number of carpet cleaning, right? 1,315 and 0.789 of somebody's carpet. Okay, there's no such thing. We need to recommend a round number of carpet cleanings. So the appropriate thing to do to make sure that Gallant Carpet Cleaning covers their costs, in general with break-even points, is bump it up. When you bump it up, you cover that one last little scrap right there. And we know for a fact it will cover its cost and like a few cents of clear profit at 1,316. Oh, which means that actually, to finish the table, we'll go right there. Now, okay, so we've done a bunch of calculations, but wait, what actually was the question? The question was machine B, okay, this one, needs to clean how many more carpets than machine A? Oh, or which is to say, this 1,316 is how much more than the 625. Oh, the question is actually asking for not either one of those quantities, but the difference between the two. Well, we can do that. That's just simple arithmetic. 1,316, that's machine B, minus 625 reveals, I get 691. 691 more carpet cleanings. That right there answers the question. The more expensive, more sanitary, but more expensive machine B has to clean 691 more carpets before it will cover its costs relative to the less expensive, less sanitary machine A.